In this video, you will learn three different constructions, and the first is how to divide a segment into a given number of congruent parts. The second is if you're given three segments, to construct a fourth segment so that the four segments are in proportion. And the final construction is to construct the geometric mean of two segments. So beginning with the first construction, we are going to take a segment, and in this case we want to divide the segment into three congruent parts. And this process we're going to show you can be used to divide a segment into any number of congruent parts. What you do is, if you're given a segment, you want to create a ray like this from this one point. All right, and then what you do is you take your compass, and you can make your compass any length, doesn't matter, and you're going to mark off a point here. Don't change the length of your compass. Pick it up, put it here at this point, and make another mark right there. Pick your compass up again, make another point, and you do this however many times you want to divide the segment. So if you want to divide into three parts, you do it 3 times, you get 3 points. If you want to do it in 4 congruent parts, you would do it a 4th time. 5 congruent parts, you make 5 points, etc. All right, so what you do from here is we're going to connect this last point that we have with the other endpoint of the segment. And then what we're going to do is we're going to basically create parallel lines to this segment we just created right here. All right, so to do that, okay, we're going to take your compass on this point. You're going to create an arc like that, and then we're going to do that for each of these points. Create an arc, pick it up, move it over here, create another arc from that point. And then what we're doing is we want to measure the distance from those 2 intersection points of that first arc that we created. So you measure and then pick up your compass, don't change the length, put it here, mark off that point, move it over here, mark off the point on that arc, and we just connect the points. So right here, these 2 points we can connect, and then these other 2 points we connect, and now we have created this segment up here now into 3 congruent parts. Right, so from here to here is one part, from there to here is a second congruent part, and from here to the end is the third congruent part. So that's your process for dividing a segment into any number of congruent parts. So again, if there's four parts you want or 5 parts you want, you would do the same thing, but have 4 or 5 lines to make this happen. All right, our second construction is going to be given 3 segments. And what we want to do is we want to construct a 4th segment with length x, such that a over b equals c over x. So we want this to be in the same ratio. So the length of a divided by b, we want it to be the same ratio as c divided by some unknown length we'll call x. So the question is, how long would the segment need to be to create this in proportion? So the steps for doing this. Okay, we begin by creating any angle. So we want it to be acute. Let's make an acute angle like this, any size. And what you're going to do is, you see this ratio right here, a over b. You're going to take your compass and measure the lengths of those segments. And so we have the length of a, we can measure, and we mark it off down here. So that's the length of a. All right, and then we measure the length of b, and then add that to this segment here. So we go to this point we just created, mark off the length of segment b, and to get this point right here. All right, so what we have is the length of a, and this is the length of b. And then what we do is we can start looking at this other side over here. We can measure the length of c with our compass and make that mark right here. All right, so once we have that, we will connect the points, these endpoints right here. So we have that connected, and then what we want is going to be a parallel line to that from this point. So it's going to look something like this. All right, whatever this length is, that's going to be the length of x. So the question is, how do we make that segment? Well, to construct it, we want to take our compass and we want to measure or create an arc. Doesn't matter the length of the compass, but you make an arc like this right here, and we're trying to duplicate this angle. See the angle right here? We're trying to duplicate it. So we take our compass down here to this point and then create an arc like that. And it just happens to be the same length to get to this point. It doesn't have to be to that point. You keep it the same length as whatever this arc was. All right, and then from here, we want to measure the distance between those intersection points of that arc we created, and then use that same compass length to find the this point right here on the same arc. All right, so we found that point, the intersection point on this arc, and so now we just connect the dots. We connect this point with that point, and there we have it. So this here, so you see it, so let's change the color right here in red. Okay, that length is the length of x. All right, so that is our segment, and if you want, you can duplicate it over here if you wanted, or you just leave it like that here in the picture. And it makes sense because if you think of this ratio a to b equaling c over x, okay, c is smaller than a, so that means x would have to be smaller than b. So this segment makes sense. It's smaller than b, so we did it correct. Now our third and final construction, we are trying to construct the geometric mean. So we're given segments with length of a and with length of c, so not b but c. And what we're trying to do is we're trying to construct the geometric mean. Or in other words, we're constructing a segment of length x such that a over x equals x over c. Right? That's what geometric mean means. Right? Remember doing that? So if we had, if you were told to find the geometric mean of 4 and 6, what you do is you do 4 over x equals x over 6. And you find that, you cross multiply, get x squared equals 24. So x would be the square root of 24. And that would be your geometric mean. So we've done that in the past, and here, just a reminder, that's what we're doing as well. But we don't know the length of a and c. We don't have actual numbers per se. But it's going to be a over x equals x over c, just like we had 4 over x equals x over 6. Or another way of saying that would be right here, x is the square root of a times c, just like we got down here with the actual numbers. X was a square root of 4 times 6. So again, we don't have actual numbers to put in there, but that's the concept of what we're doing. And by the way, remember in a previous lesson, this was probably a while ago, if you were given a right triangle, so I'm just kind of sketching this freehand, if this is a right triangle, or this is a right angle, and you had an altitude created like this, okay, we were told that this segment here, that altitude is the geometric mean of whatever these two lengths are. And so that's what we're really trying to do, is we're trying to reconstruct this triangle because whatever this length is, that's going to be the geometric mean of these two segments. All right, so that's kind of big picture. What we're trying to do is create or reconstruct this triangle with this altitude. So to make that happen, we want to begin by drawing a straight line and make it longer than a and c would be put together. And what we want to do is we want to measure the length of a, put it down here. So length of a, that takes you to that point. And then measure the length of c, and then put it right here. And then we get that second point. And again, what we're trying to do, I'll just kind of sketch it, is we're trying to create an altitude from this point so that we have a right triangle like this. All right, so once we have that picture, whatever this altitude is that makes this right triangle, we have our value for x. So one of the things we'll need to do in a minute is we're going to have to create a perpendicular line through this point, and then we also need to do one other thing. So the one thing we want to do is we want to basically create a, or find the midpoint of the segment from here to here. So to find that midpoint, okay, we want to perpendicular bisect. So just make your compass any length longer than at least halfway. So create an arc here, pick your compass up, move it over to this point, create another arc with the same arc length, and then see where they intersect. So they intersect here and here. You connect the dots, and we get this perpendicular line. And the intersection point is right here in red. So we use this point as our center point, and then we create an arc, or actually a semicircle, with the radius from that center to either endpoint. All right, so you create a semicircle like this. All right, so you just connect that circle or that point to this point over here with an arc, with a smooth curve. And then we're going to do that second thing that we mentioned, which was create a perpendicular bisector through this point right here. All right, so through this black point right here, we're trying to create a perpendicular bisector. So you take your compass and you make an arc, and you want to figure out where it intersects. So it intersects here and here. So we're now going to use these points and this segment connecting those points, and we just create a perpendicular bisector with that. All right, and that will go through this black point here that we wanted and create that perpendicular line. So we perpendicular bisect that segment. So we put our compass here on this point, create an arc, and then you put your compass over on this other endpoint, create an arc of the same radius, and you see where those arcs intersect, which is here and here. You connect the dots and you get your perpendicular bisector. So we can erase the arcs and those points, and now what we want is this point right here where that semicircle and that perpendicular bisector will intersect. All right, so now that we have that point, okay, that point indicates the segment length. So from here to here, see in green, that segment, that is your length of x. And we're done. And this works because what we've created is a right triangle if you connect those endpoints with this point right here. Okay, it's a right triangle with this as an altitude, and has this segment is the length of A and this segment is the length of C. And again, remember, with this setup, with this right triangle picture, this altitude is the geometric mean of A and C. So the length of x right here, from that point down to here, that is the length of your geometric mean. And that concludes our lesson for today. We will see you next time.